was legit surprised.
I'm waiting for. Hello.
Okay, hello everybody. If you can hear me, kindly indicate that you can hear me.
Yes, I can hear you. I can hear you.
Okay, actually, not you, I mean the students.
Okay, okay.
If you can hear me, um, kindly type, say yes, I can hear you. I'm waiting. Okay, very good. Okay, very good. Okay, as we all know, I am overburdened by many of the subjects. So I have with me here Mr. Chibuzor. Don't worry, we don't have a screen yet. He will soon be sharing his screen. Okay, so Mr. Chibuzor would continue as our math tutor. Okay, good. So he is here. All he just needs is your cooperation, and he's very, very good. Okay, so I will be on the background, listening to the lectures. So, Mr. Chibuzor, the floor is for you. I'm logging. I'm exiting.
All right. Thank you so much, sir. Good evening, class. I hope you all can hear me. Can you all hear me? Please indicate if you can hear me. Okay. Okay, I see you. All right. So today we are going to study initial equation. Can you hear me? Good evening. Okay, you can hear me. Okay. So today I hope you all can see my screen. Today we are going to study initial equations. So what's initial equation? Initial equations are equations that have unknown letters or unknown numbers as an index in their equations. I can't see your screen. Can you see my screen, please? Please indicate if you can see my screen all. Okay. Okay. So what are initial equations? Initial equations Initial equations are equations that have unknown numbers or variables as an index. You know, when you have a linear equation, for example, 2x is equal to 4. That's a linear equation. Example, 2x is equal to 4. That's a linear equation. But for initial equation, you have something like 2x 2x is equal to 8. Two x is equal to 8. So before we go on with initial equations, I hope you all have a background on indices, because indices will give you the basics to follow up with initial equation. In indices, you must have understood the laws of, exactly, that's 2 raised to power 3. In indices, you must have understood the laws of indices. So before we go on, I would like us to have a recap of laws of indices. So for us to have a recap of laws of indices,
Please increase your board, sir. Increase the size
okay,
of your
okay,
board.
okay. How is it now, please?
Yeah, you can increase more.
Okay,
Yeah, good.
okay,
Then
okay,
you click on that draw, then reduce the thickness of the pen.
okay.
Yes, reduce it. Good. You
All right.
can check if it's okay for you. Good, good.
So let's have a recap of laws of indices. For the first law, we have multiplication law. Here we have that any number, when numbers have the same base, we multiply, we add their bases. For example, when we have 2 raised to power 3 times 2 raised to power 3.
Sorry, sir, for cutting your class short.
Okay.
I think you can just go straight to the initial equation. They already did this very well.
Okay. I
It's
just wanted to know that you guys are in tune with the laws of
yes,
indices.
they are in tune. Just move on.
Okay. So let's just progress to, okay. Let's just progress to initial equations then, since you're already in tune with. So for initial equations, like I said, initial equations are equations where the unknown number are indexed. For example, in linear equation, you will have something like 2x is equal to 8. But in initial equation, you'll be seeing something like 2x is equal to 8. Here, the unknown number x is an indices, is a power, unlike a linear equation where it is 2x is equal to 8. So before we go on, there are types of initial equations that you face when you are solving an initial equation. For the first one, you have a simple initial equation. A simple initial equation. Here you will have to match the base or make the bases equal. For example, if you have 3x is equal to 27. To solve this, you have to make the bases equal. By this, I mean you have to express 27 as a power of 3. And how do you do that? How do you do that? We know that 3 raised to power 3 is equal to 3 raised to power 3 is equal to 27. So we can say 3 raised to power x is equal to 3 raised to power 3. Here we have that the two bases are equal. Now that we have that the two bases are equal, we can cancel out 3. And we have that x is equal to 3. Who is asking law of indices? Okay, let's progress. Are we clear with the first type? Okay. What about law of indices? Someone is asking law of indices. So if we are clear with the first type, we can go over to the second type. The second type, you have to face equations that require fractional or native indexes. Equations requiring fractional indexes. So this is for the first type. Example of this, we'll see equations like find x in this equation. Here we are facing equations that require fractions. Unlike the first one that was just basic, the first one we saw that 2x is equal to 8, and we simply had to convert this to 2 raised to power 3, 2 raised to power 2x, and cancelled out 2. But here we are having fractions. So what do we do? From our knowledge of laws of indices, we'll have to find the common basis and solve it. How do we find the common basis? The common basis of 9 and 27 will be 3. 3 raised to power, for 9, that will be 3 raised to power 2. And for 27, that will be 3 raised to power 3. So when you know this, you can now go on 3 raised to power 2 in brackets. Now you've gotten the power base of 9, which is 3 raised to power 2 raised to power x minus 1 is equal to 1 over 3 raised to power 3. Are we clear? Is my screen breaking? Is my screen clear? Okay, we'll progress. The screen is breaking. How is my screen breaking? How is my screen breaking? Okay, so progress. Now that we've gotten the power basis of 9 and 27, we can now apply the laws of indices to both sides. If you're applying the law of indices to this one, that will be 3 raised to power 2. You open the bracket, 2x minus 2. That's 2 times x is 2x. 2 times minus 1 is minus 2. And then you go over to the other one. Remember that in the law of indices, if you have 3 raised to power minus 3, that will be 1 over 3 raised to power 3. Are we clear? Great. So since we are trying to get the basis to be the same thing, we'll now reverse this one back to its state before it was converted using the law of indices. Are we clear? So now that we've converted it to this, we can now easily cancel out 3. When we cancel out 3, we will have 2x minus 2 is equal to minus 3. Hope we are following. Please indicate if you are following. All right. So let me clear the board so that we'll have space. So now that we have 2x minus 2 is equal to minus 3, we can easily find x here. 2x minus 2 is equal to minus 3. We can easily find x by collecting like terms. Collect like terms. This will give us 2x is equal to minus 3. Minus 2 will cross over and become plus 2. So now we are left with 2x is equal to minus 3 plus 2 is equal to minus 1, right? So we are now left with x is equal to minus 1 over 2. Is that clear? All right. So we'll go on to the type 3. Type 3 of indicial equations. So for type 3, we'll be having equations that lead to quadratic equations. Indicial equations that lead to quadratic equation. Okay. So for this,
Hello, sir. So sorry
okay.
to cut you short. The quadratic equation, they don't know it. They've not done that yet.
Oh,
So
okay,
you
okay,
just
okay,
maintain, yeah, you maintain the other ones.
okay, 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 okay. All right. Okay. So I'll go over to the type 1 again and recap it. When I recap it, I'll give you guys another examples, and then I'll still go over to type 2 and give you examples as well. So I don't know, is there a way that I can add a new page to this so that I don't
A new
have to
page.
always, yes, so I don't
No,
have to
just
always,
refresh your screen. Everything will go out.
okay, okay, thank you. Okay,
There is this up there, up, yeah, your up left. Yes, that circle
yeah,
sign.
yeah, I got it,
Exactly.
I got it, I got it, I got it. Okay, so like I said, indicial equations are equations where the variables are an index. Let me type it so that you guys can have a clear knowledge of it. Okay. So initial equations are equations where the variable or unknown number appear as an index. The difference between an initial equation and a linear equation is that in initial equations, the variable appear as an index. When I say an index, I mean it appears as a power raised to. That's what an index means. But in linear equation, the unknown number is not an index. The unknown number is the same as the base numbers. I'll give you another example. For an initial equation, when you have something like, for an initial equation, you will see something like x is equal to 27. This is initial equation. But for linear equation, you will have 3x is equal to 27. So this is the difference between linear equation and initial equation. But we are not studying linear equations today. We are studying initial equation. So for type 1 of initial equation, the base, you simply have to match the base of the equation. This is one example, number 1. 3 raised to power x is equal to 27. Find x. Solution. 3 raised to power x is equal to 27. To find this, you have to make the bases equal by finding the common base of the both. So the common base of the both will have to be 3. Since this 3 is already here, you have to find what will be raised on 3 to give you 27. That means 3 times 3 times 3 times 3 times 3, 1, 2, 3, 4, 5. That is, no, sorry, excuse me, that is. So 3 times 3 times 3 is 27. So you say 3x is equal to 3 raised to power 3. So now we've succeeded in having the basis as the same thing, 3 and 3. So what do you now do? You cancel out the common basis, which is 3 and 3, and you have x is equal to 3. That's the answer. Exactly, x is equal to 3. I'll give us another example. Type 1. Four raised to power x is equal to 16. So I'll give you guys time to solve this one. Let me see the first person that will get the answer. Using the same principle by matching the bases. Nice. X is equal to 2. X is equal to 2. That's the answer. So when you're solving this, you say 4x is equal to. So remember, our target is to match the bases What will be raised to 4 to get 16? That is 4 raised to power 2, because 4 times 4 is equal to 16. 4 times 4 is equal to 16. So since that we have that 4 raised to power 2 is equal to 16, we have succeeded in matching the bases. The bases are now the same thing. So we cancel out 4 since we have the same basis. That is x is equal to 2. That is the answer. Correct. Correct. X is equal to 2. Is there who got it first? Angel Fortune, you got it first, right? Yeah, you got it first. Or was it Ugochukwu? I think Ugochukwu got it first. Okay, I'll give you guys another example as well. So let's see who will get this one. All right, let's see who will get this one. Nice, nice, nice. Gino Kereke, you got it. That's the answer. That's the answer. 7 is equal, x is equal to, find x. So using the same principle, 7 times 7 is equal to 49. That means 7x is equal to 7 raised to power 2. And when you cancel out 7 and 7, you will get 7 is equal to 2. So that's correct. That's correct. Angel Fortune, you got the answer first. Nice, correct. I'll give us another example. So let's see who will get this one first. This is a new question. Let's see who will get this one first. Nice, nice. Stanley. Stanley, you got this one first. That's correct. That's correct. I see you guys already understood the type 1. That's correct. 3 is the answer. Okay, so how do we solve this? Using the same principle, we already have the base of this. So we now say 5 times 5 times 5. 5 times 5 times 5 is equal to 125. That means 5 raised to power 3. So since we have established that it is 5 raised to power 3, we can now say 5y is equal to 5 raised to power 3. And now that we have the basis as the same thing, we can cancel out 5 and 5. We have 5, y is equal to 3. That's correct. Okay, we have another example now. This one will be a little bit tricky. This one will be a little bit tricky. So let's see who will get this one. Nice, nice, nice. I'm impressed with your attempts. Impressed with your attempts. Let's see more answers before I give you guys the correct answer. Let's see more answers before I give you guys the correct answer. Any more attempts? Okay. So if you said 4/3, you are correct. So Gina Okereke got it first, I suppose. Yeah, Gina Okereke got it first. No, 4/3 is the answer. How do we solve this? Since we have 4 as the base with the index, we have to convert 16 to 4 to the base of 4. And how do we do that? 4 times 4 is equal to 16. That is 4 raised to power 2 is equal to 16. So since that we've established that 4 raised to power 2 is equal to 16, we now say 4 3y minus 2 is equal to 4 raised to power 2. Right? Now we have the bases as the same thing. We cancel out 4 and 4. If we cancel out 4 and 4, we'll have 3y minus 2 is equal to 2. So how do we do this? We collect like terms. That is 3y is equal to 2 minus 2 will cross over and become plus. That is 2 plus 2. So we have 3y is equal to 4. Divide y by the coefficient of, divide this by the coefficient of y, which is 3. We have 3y over 3 is equal to 4 over 3. This will cancel out this one. We will now have y is equal to 4 over 3 as the answer. Congrats if you said 4 over 3. What if someone is asking a question? So what if you change it to mixed fraction? That is correct. If you change it to mixed fraction, it's still correct. So if you are changing it to mixed fraction, you can say, oh, I need space. Okay. 4 over 3 is equal to so that is the same thing. Is that what you got? Angel, is that what you got? Okay, Ni Be Ogene. You said you don't understand. Please, what don't you understand? Let me know what you don't understand. Ni, what don't you understand? Okay, I'll repeat the entire process so that Ni, if you don't understand, you can understand it now. I said 4, I need a black one. 4 raised to power 3y minus 2 is equal to 16. If we are solving an indicial equation, our first target should be to make the two bases, this basis and this one, to be the same thing. How do we do that? We know that 4 times 4 is equal to 16, right? And 4 raised to power, this means 4 raised to power 2 is equal to 16. We now say 4 raised to power 3y minus 2 is equal to 4 raised to power 2. So that we'll have these two bases as 4. Since we have them as 4 now, we can easily cancel out. If we cancel out, we will now be left with 3y minus 2 is equal to 2. So when we have 3y is equal to 2, that will now be that will now be 3y. You collect like terms, 2 plus 2. That will now be 3y is equal to 2 plus 2 is 4. Divide both sides by 3. Divide this by 3. Divide this by 3. Then you cancel out 3 and 3. You'll be left with y is equal to 4 over 3, or one whole number 1 over 3. Do you understand now? The one you are explaining now. Okay. But do you understand it now? Okay, okay. So I'll give you more examples before we go over to type 2. I hope we all understand this one. Do we all understand? Okay, I'll give us another example. This one will be a little more tricky as well. For 4x is equal to 32. Let's see who will get this. Find x. So let's see who will get this. More attempts. More attempts. Okay, I think we have our answer here. Ugochukwu said 5/2. Ugochukwu, you are right. So how did we arrive at 5/2? Let's solve this. Now, remember that our target is to have the basis as the same thing. The basis, which is this and this. But the problem here is that 4 times 4, or if you keep going, you can't get to 32. You can't find 32. It's not equal to 32. So what do we do? Since we can't convert 4 to be an index power of 32. What do? We now say 2 raised to power 2. This 2 raised to power 2 is equal to 4, right? That is 2 times 2 is equal to 4, right? Now say 2 raised to power 2 with, in brackets, x, right? Because 2 raised to power 2 is equal to 4. This thing now is the same thing as this. 2 raised to power 2 in brackets x is the same thing as 4 raised to power x. And also say 2 raised to power 5. 2 raised to power 5 is equal to 32 now, right? Right? So since we now have that 2 raised to power 2x is equal to 2 raised to power 5, we can now cancel out this. and say 2x is equal to 5. That means x is equal to 5 over 2. Is it clear? Remember, our target is to have the base as the same thing, but 4 is not an index of 32. So what do we do? Since 4 does not have a number that you raise it to and it will give you 32, you use 2, which is the common base. 2 is the common base. 2 raised to power 2 will give you 4, and 2 raised to power 5 will give you 32. So you now change 4 as 2 raised to power 2 in bracket x, and then do for the other side 2 raised to power 5. Then now cancel out 2 and get 2x is equal to 5. This will give you x is equal to 5 over 2. Is it clear? So you will not always have the base as easy as, okay, you got it. You will not always have the base as easy as, say, 2 raised to power 2 and equal to 2 raised to power 3, like the other ones we've done. You can always expect it to be this tricky. So when you find something like this and you realize that you cannot have the same as the base, well, you now have to convert the first one to match with this one. So that is what we did here. I'll give us another example so that you will try it. Okay. So let's try this one. Right. I see we all got this one. It's 1. Hello, Rubik's. I see we all got this one. The answer is 1. So how is it 1? Let's solve. Nine raised to power 2x is equal to 81. 9 times 9 is equal to 81, right? That means 9 raised to power 2 is equal to 81. So you now say 9 raised to power 2x is equal to 9 raised to power 2. When you have this, you can now cancel out 9, cancel out 9. So 2x is equal to 2. X is equal to 2 divided by 2, which is equal to 1. 1. X is equal to 1. I hope that is clear. I hope that is clear. More examples. Let's attempt more examples. Do you have any questions? Do you have any questions? Please ask your questions if you have any questions. Okay, we'll attempt one more question before we go over to type 2.
Hello.
All right, so we have a clear understanding of type 1. Who say no? Okay, no questions. Okay, we have a clear understanding of type 1. So we'll go over to type 2. Remember, the first type is a simple equation where you just have to convert the bases to the same thing. But type 2, you have to expect fractions, equations requiring fractions. Fractional or negative indices. Okay. So I gave you the first example, which was 9x minus 1 is equal to 1 over 27. This is the first example I gave you for this type 2. We'll have a recap of it. We have the bases as 9 and 27. So what do? We convert, we make the bases the same thing as the power of 3. Here we say that 3 raised to power 2 is equal to 9, right? And 3 raised to power 3 is equal to 27. So since we've established that 3 is the common base, what do? We say 3 raised to power 2 x minus 1 is equal to 1 over 3 raised to power 3. I've solved this one before. I'll just use it as a demonstration for the first example of this type. So here we have that 3 raised to power 2 in brackets x minus 1 is equal to 1 over 27 is equal to 1 over 3 raised to power 3 now. What do? In the law of indices, we know that any number that is raised to a negative number, say for example 3 raised to power minus 3 is equal to 1 over 3 raised to power 3, right? This is what inverse laws says. So since we have this law already in our knowledge, we have to reverse this 1 over 3 over raised to power 3 back to 3 raised to power minus 3 so that we can easily cancel this and this and this. Okay. So now what do? We say 3 raised to power 2x minus 1 is equal to 3 raised to power. Do you understand it up to this stage? Do you understand this step? Okay, good. So since we have this, we can cancel out 3 and 3. And we now say 2x minus 1 is equal to minus 3. Expand the bracket, we have 2x minus 2 is equal to minus 3. 2x is equal to minus 3 plus 2. 2x is equal to minus 1. X is equal to minus 1 over 2. Is it clear? Clear? Good. 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 Okay. So let's do another example. Please explain how we got minus 2. How we got minus 2. Someone said I should explain how we got minus 2. Okay, this is the minus 2, right? Here is the minus 2. How we got it, we expanded the bracket. We expanded the bracket. We said 2 times x is equal to 2x. 2 times minus 1 is equal to minus 2. So that's how we got the minus 2. Do you understand now? Ami, do you understand now? Emi, do you understand now? Okay, okay. And I said I should repeat it. All right, no problem. I'll start from the beginning. And I said I should repeat it. Okay. So this is the question we solved. 9x minus 1 is equal to 1 over 27. No, this is not the one we solved. This is the previous one. We had, oh yeah, it is. It is. This is what we solved. Here we are asked to find, and I am explaining to you now. Here we are asked to find the value of x. Remember, when you are solving initial equations, your target, your first step is to try and convert the bases to the same thing. When you convert the bases to the same thing, it will now be easy for you to cancel out. What do I mean? Since we already have that 9 is the base here and we have that 27 is the base here, we cannot cancel out both of them until we have a common base. But how do we get a common base? We know that 3 times 3 is equal to 9. That is 3 raised to power 2 is equal to 9. We also know that 3 times 3 times 3 is equal to 27. That is 3 raised to power 3 is equal to 27. So with that knowledge, we can now say 3 raised to power 2 in bracket x minus 1. This thing we've converted here is the same thing as this, because 3 raised to power 2 is equal to 9, and we also have that it is raised to power x minus 1. So we've converted it to this. We go over to the other side, we convert 27 as well. 3 raised to power 3. And do you understand it until this stage? And do you understand it until this stage? Okay, good. So since we have it to this stage, you already had your law of indices. You already have an experience of the laws of indices. So you apply the laws of indices when you are solving indicial equations. For this part, we know that if a number is raised by, if we have something like a raised to power x in brackets x in brackets y. This is the law of indices now for the product law. When we have something like this, that means it is also equal to a raised to power x y. That is x times y, right? So this law is what we applied here. We say 3 raised to power, multiply this 2 with the whole bracket. 2 times x is equal to what? 2x. 2 times minus 1 is equal to what? Minus 2, right? We go over to the other side. We also apply the law of indices. In the law of indices, if we have a number like a raised to power minus x, the general law means that a is equal to 1 over a. This is what this means. This is what this means. When you have a raised to power minus x, it is the same thing as 1 over a raised to power x. So that law is what we applied here. Since we already have it here, we have to revert it back to. Why are we reversing it back? So that we can cancel out this tray and this tray, right? Do you understand? Okay, good. So now that we've reversed it, we can now cancel out tray and tray. If you cancel tray and tray, you will have 2x minus 2 is equal to minus 3. So what do? Remember, we are trying to find x. So we say 2x is equal to minus 3. You collect like terms, minus 3 plus 2. So when you've done this, you say 2x is equal to minus 3 plus 2 is what? Minus 1, right? So x is equal to minus 1 divided by 2. Understood? And do you understand now? Okay, you understand. Okay, good. So we solve another equation. I'll get us another equation now. So let's attempt this and see who will get the answer. Find x. So let's attempt this and see who will get the answer. Okay. Ugochukwu said 6. Brian said 6. You both are correct. Congrats, you both got the answer. So how did we arrive at 6? We have 27x plus 2 is equal to 9 2x. Here we know that the common base will be 3, right? Because 3 times 3 is equal to 27. 3 times 3 is equal to 9, excuse me. 3 times 3 is equal to 9. And 3 times 3 times 3 is equal to 27, right? That is 3 raised to power 2. And this one is 3 raised to power 3, right? So having established that 3 is the common base, what do we say? We say 3 raised to power 3 x plus 2 is equal to 3 raised to power 2 2x, right? So since we have it as the common base now, we cancel out 3 and 3. So having cancelled it out, we are left with 3x plus 2 is equal to 2 in bracket 2x. So what do? We open the brackets. We say 3x plus 2 plus 6. 3 times 2 is what? 6. 3 times x is 3x, and 3 times 2 is 6. So we say equal to 2. 2 times 2x is what? 4x. Now we go on to collect like terms, right? Did you make a mistake? Okay, no. 3x, 4x will cross over here. It will become minus 4x is equal to 6 will cross over here. It will become minus 6. So we subtract this one. 3x minus 4x is equal to what? Minus x. That is minus 1. But since we cannot write 1x, we remove 1. So we say this x minus 6. Minus will cancel out minus, and we have x is equal to 6. I hope this is clear. Okay. Enjoy say you said you saw your mistake. Where did you get it wrong initially? These ones that solve these things in seconds, please be waiting for us. You don't have to have them wait for you. You take your time. Most important thing is you have to understand the steps. When you master the steps and the approach you need to follow, it will be easy for you. So I'll give us one more example from here. Okay, let's attempt this one. Let's attempt this one. This one is quite tricky, but I believe if you put on the steps we've already studied, it will be quite easy for you to solve. Is equal to 32 x plus 2 divided by 4 minus x. So let's solve this and see who will arrive at the answer. Well, I think this one will lead to quadratic equation. Are we still attempting? Okay. Okay. So we have someone say minus 19 over 4. That is the answer. Brian said minus 19 over 4. That is correct. Minus 19 over 4. That is correct. Or 4 points, or minus 4.75. Okay, that is correct. So how do we solve this? So like I've always said, when you're solving initial equations, your first attempt or your first target should be to have the basis as the same thing. By that I mean you ask yourself, which number can be raised, can be turned to an indices that will have the same base for each of them. For each of them, I mean for 8, for 32, and for 4. That is 2. Because when we have 2 raised to power 2, we will have 4. When we have 2 raised to power 3, we will have 8. And when we have 2 raised to power 5, we will have 32. So having established that 2 is the base, common base, what do? We substitute 8 with 2 raised to power 3 in bracket x minus 3. Then we go over to the other side. We substitute 32 with 2 raised to power 5 in bracket x plus 2 divided by 2 raised to power 2 minus x. I hope it's clear until this stage. Please indicate if you understood it, this stage. Please indicate if you understand until this stage. Okay, good. Okay, good. Good. So, what do we now do? We apply the law of indices. We'll open up this side. We'll say, okay, we can just leave this side first. I need space. Two raised to power 3 x minus 3 is equal to 2 raised to power 5 x plus 2 divided by 2 raised to power 2 minus x. I hope you understood, because this is 2 raised to power 5 in bracket x plus 2 divided by 2 raised to power 2 in brackets minus x. I just converted the division sign to this so that it will be easy for us to understand. So in the law of indices, we have the division law that states that if a raised to power x divided by a raised to power y, we have a x minus y. So this is the general law for division law in indices, right? So since we've already had the knowledge of this division law, we apply it here. By applying it, we'll have, by applying it this right hand side, we'll have 2 raised to power 5 in bracket x plus 2 minus 2 in brackets minus x, right? But this side you have 2 raised to power 3 x minus 3, right? Understood? Okay, good. So we've succeeded in having a common base, which is 2 and 2. So now we have a common base. What do? We cancel out 2 and 2. When we cancel out 2 and 2, we'll be left with 3 in brackets x minus 3 is equal to 5 in bracket x plus 2 minus 2 in brackets minus x, right? So we open up the bracket. When we open up the bracket, we have 3x minus 9. That's 3 times x will give us 3x. 3 times minus 3 will give us minus 9 is equal to 5 times x will give us 5x. 5 times 2 will give us plus 10. We say minus 2 times minus x will give us what? Plus 2x. Right? So at this stage, what do? We collect like terms. What do? We collect like terms. So when we collect like terms, we'll have 3x, 5x will come over to this side. Or we can just finish up this side first by collecting the like terms of this side. We'll say 3x minus 9 is equal to 5x plus 2x plus 10, right? Here we collected these like terms. We'll have 3x minus 9 is equal to 5x plus 2x will give us 7x plus 10. Okay, so we'll come over to this side. We'll say 3x minus 9 is equal to, I'll bring it to this side first, plus 10. So we are still collecting like terms. We'll bring this x and 3x and 7x together. That will be 3x. 7x will come over to this side, will give us minus 7x is equal to 10. Minus 9 will cross over to this side and it will now become 19. Plus 9, I mean. So here we have 3x minus 7x will give us what? Minus 4x is equal to 10 plus 9 will give us what? 19. So divide both sides by 4, by minus 4. We'll have minus 4x over minus 4 is equal to 19 over minus 4. So this will cancel this. We'll have x is equal to, we have x is equal to minus 19 over 4 as the answer. That's what we got, right? Exactly. But Ugochukwu, you don't say 19 over minus 4. That minus is for both of them. You just say minus 19 over 4. It's the same thing, but this is the more appropriate way to write it. Ugochukwu, you understood me, right? Ugochukwu, hope you understood me. So Darasimi, you said it's too long, but it feels so easy. Yes, when you know the approach, when you follow the right step, it will be easy for you, regardless of how long it is. That is how mathematical problems can be. They can be quite long when you are solving them, but when you know the steps to follow, it will be easy for you. And the good thing is that in your examination, if you are following the right step, every step you follow correctly will fetch a mark for you. Every step you follow correctly will fetch a mark. Even if at times, even if you don't arrive at the correct answer, if you're writing your WAEC, for example, if you don't quite arrive at the correct answer, each step will have a mark for you. So it's very important for you to always follow the right approach and the right step, every step of the way. I hope you understood this. Okay, good. Not too long, actually. Okay, good. I want to give us another example. So let's attempt this. Okay. Let's attempt this. This should be easy for you, of course. This should be easy for you. Two, correct. Gino Kereke said two. That's correct. That's correct. The answer is two. That's correct. So two is the correct number. 16 will have to cross over. Let's give this a try. I'm trying to find another complicated question so that we can attempt it together. So let's try this. Find x. Okay, let's try this. Has anyone gotten the answer yet? Okay, let me solve this. Okay, how do we approach this? We know that 3 is the common base because 3 raised to power 2 will give us 9. 3 raised to power 4 will give us 81. We already have these 3 and we already have these 3. So what do? We say 1 over 3 raised to power 2 in brackets x is equal to 3 raised to power minus x divided by 3 times 3 raised to power 4 in brackets x. Now, remember that in indices, if you have a number like this, what it means is that it is raised to power 1, right? So here we have 3. So we acknowledge that we have 1 here. I hope you understood this. Please indicate if you understood it to this stage. Can we indicate if you understood it to this stage? Just indicate if you understood it. Okay, good. Anna, you understand? Do we all understand to this stage? Okay, good. So what do? We open up the brackets. We say 1 over 3 raised to power 2x. That's 2 times x will give us 2x. We come over to this side, we say 3 raised to power minus x divided by 3 raised to power 1 times 3 raised to power 4x. We come over to this side, we say 3 raised to power 2x is equal to 3 minus x. 3 raised to power 3 raised to power minus x divided by. In the law of indices, we have multiplication law stating that a times a, 4 and 3 is equal to a 4 plus 3, right? This is what law of indices states, multiplication law. So when we apply that here, we have 3, 1 plus 4x. Understood? So we'll say 1 over 3 raised to power 2x is equal to 3 raised to power minus x divided by, 3 raised to power minus x divided by 3 raised to power 1 plus 4x, right? Also, in the law of indices, we have division law stating that a divided by a 4 minus raised to power 3 will be a 4 minus 3, right? So we apply the law here. We say 3 minus x. This will subtract this base. So that is what law of indices says. Minus x minus 1 plus 4x, right? So here we still have this one in an inverse shape. So we have to convert it by saying 3 minus 2x is equal to 3 minus x minus 1 plus 4x. Understood? We only converted this one now to this. So now that we have it as the same base, we can cancel out 3 and 3. We'll be left with minus 2x is equal to minus 1, minus x minus 1 plus 4x. I hope you are following. Good. So what do? We collect like terms. We say minus 2x is equal to minus x plus 4x minus 1. Collect like terms, x and s comes together. You have this. So what do we get? 4x minus x. That's x minus x plus 4x will give us what? Minus 3x minus 1. Right? So what do? We say okay, we still collect like terms again. Minus 2x minus 3x, because 3x will come over to this side and it will be minus, is equal to minus 1. So when we subtract this one, what do we get? Minus 5x is equal to minus 1. X is equal to minus 1 divided by minus 5. X is equal to 1 over 5. Is it clear? Do you understand? Do you understand? You keep saying that it's long. Like I told you guys, mathematics, some problems you have to undergo a long process to solve it. You can't maneuver it. That's how it goes. But if you follow the steps correctly, you will definitely arrive at the answer. And the good thing is that when you're solving it and you are asked to show full working, when you're solving it, for every step that you get right, you will get a mark for it, even if you don't always arrive at the right answer. But it's important for you to arrive at the right answer. But even if you don't always arrive at the right answer, for every step you get, you will have a mark. But I challenge you guys to always arrive at the right answer when you're solving it. But if you don't understand, I can go over it again if you don't understand. Is there anyone that does not understand this? Is there anyone that does not understand this? And I hope you understood it, even though it's long. Okay, I'll give us another question. Okay, good, you understand. Good, good. Angel, good, you understand. I'll give us another question. So let's say we have okay. X raised to power 1 over 2 is equal to 4. Can we solve this? Let's solve this. Correct. The answer is 16. 16, that's right. So Brian, you said 16. That's correct. Stanley, you said 16. That's correct. The answer is 16. How did we arrive at 16? X raised to power 1 over 2 is equal to 4. In the law of indices, we have that if A is raised to power 1 over X, it will be A square root of X. So this is the general law of indices. General fraction law of indices, or root power of indices. If we apply that law here, we'll have X raised to power square root of X 2 is equal to 4. But when we are writing square roots, we don't put 2. We remove 2. But if it's cube, if it's cube like 3, we leave 3. If it's 4, we leave 4, or the rest. But when it's 2, we don't put 2. We don't put 2 here. So here we have square root of X is equal to 4. What do? We square both sides, raise both sides by 2. When we square both sides, we'll be left with this. So this is equal to these 2 will cancel out this square, and we'll be left with X is equal to 4 raised to power 2. This is equal to 16. Understood? I hope you understood this. I hope you understood this. Give me a thumbs up if you understood this. Good. 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 So let's say we have this instead. Let's say we have,
Did you hear me? Sorry, I said it's time. Time up.
oh, okay.
Yes.
Okay.
We can continue next class.
Okay. So guys, it's time. It's been a pleasure teaching you guys initial equations today. For you to get used to the steps and the formula, you have to practice. You have to solve different kinds of examples. And when you have equation, you can always bring them here so that we'll solve them together. It's been a pleasure, guys. My name is Chibuzor. I don't know if I introduced myself initially. My name is Chibuzor, and it's been a pleasure to have you guys here. Thank you. Yeah, keep practicing. I mean, you will only get better when you keep practicing. Solve different kinds of examples, solve different kinds of formulas. Okay.